So I think you know me by now. You know, I've been working in machine learning computations for about 10 years, but deep learning for the last 3 or 4. And more I'm just hanging out with AI people. And that's partially because we have a strong AI research group, and partially because everybody like me who wasn't doing AI before is now doing AI at Berkeley. So that's and so it's an interesting thing. It often brings me to situations like this. Can I do a better session summary than a mashup AI, bot would do? So that's what I'm going to try and do. And my inspiration here, and you can rate me at the end, see if I did. So I took as inspiration. I don't know how many of you ever go to humanities conferences, and they have at the end of a series of talks, they'll have a discussant. And depending on how far north and east it is, the discussant is more and more in Europe, is what I'm thinking of. Depending on how far north and east the discussant is from, the more critical it becomes. So I'm inspired by Evgeny and Boris here. This is going to be a little more critical than feel good. Okay. But I do want to start with a compliment. I think Pete, I think this role in Evgeny, I think really helped us to, I guess this isn't going to show up, to have a very comprehensive view for the conference. And so we have systems at the core, and I think we all agree that that's the most important thing. Applications, frameworks, and semiconductor, I think were key elements. That pulled in sensors, and I think we got good sensor representation. I'm supposed to summarize my own session, but I like Marian's slides so much I had to steal one of hers from another session. But I think this really shows the opportunity that by taking this much more holistic perspective, we can do something much better and much different than you're going to get just from kind of focusing on, say, the semiconductor issues or the algorithmic issues or application. And so we can truly optimize across all levels here. So I thought this kind of system, encompassing system level focus was really very good. Boris beat me to it. I mean, I think if I were to point to a lacking here, the machine learning algorithms and deep neural nets was underrepresented. And I like to divide these. I think often we talk about machine learning algorithms. There are entire conference tracks and sometimes days of conferences that talk about machine learning algorithms. And then what you see is 9 successive deep neural nets. So let's just say we're doing deep neural nets, right? For better, for worse, right? And not say, not kind of be vaguely, oh, we're doing machine learning algorithms, but actually I'm doing a deep neural net. Okay, so to get that, so I think overall we got very good comprehensiveness, and I think the quality was really good. I hope like me, you sat there and you went, wow, these are really, really good quality talks. So this is a little more in the network design and machine learning being underrepresented. You might say, well, that's for computer vision pattern recognition conference that's coming up, or NeurIPS last December, or ICCV, which has just have its paper deadline and so forth. But the work, if you're doing work in very small deep neural nets, you're still not a first-class citizen in those communities. And I'm here to tell you, SqueezeNet got rejected twice from conferences, and then they gave up, right? So it just passed its 1100th citation in 2 years, but somehow the committees felt, no, this isn't of interest to our community, right? So, and moreover, particularly in this tiny regime, if you are doing work on small neural nets, you're probably, well, if you're doing work on neural nets, you're either thinking of NVIDIA V100, or you're thinking of Snapdragon 835 or another, or a small ARM processor. You're not down in these very low power regimes. So I think this is what Pete brings to this, as we really focus on very low regime. But I think as an indication of the lack of representation here, Peter Vajda, who routinely is kind of a keynote invited speaker level at computer vision conferences, was sitting there lonely in his poster in the other room, kind of, as people might stop by. So I think we really need to up the presence of that crowd. And Asia, I only saw one paper from an Asian representative here, and I'm on the committee, so I'm part of the problem. And I think part of this is, I think when we got this started, those of us in front row here and Ian and so forth, and we thought maybe 30 people would show up, or 40 or something like that. So we didn't really think, let's really bring people internationally to this, because we didn't know we'd fill a room like this, but next year for sure. And I just want to point out, there are unicorn, multi-billion-dollar computer vision companies focused on computer vision at the edge, principally in surveillance in China. SenseTime, MagV. If you go to CVPR, these are the megalith booths, must be thousands of square feet of booth space. They have no representation here. We don't have two of the major IC and handset manufacturers, Huawei and Samsung, with any representation. And I met Professor Yu of KAIST here, who I just saw last October, or a year ago last October in KAIST, who has has an empire of very low power circuit design in Korea. If he was coming, we should have got him up here to talk, but we didn't know. Okay, so that's workshop wide, but I think we're off to a great start, and we can address these next year. So let's focus. I did want to recap. So looking at the applications, I really like Hans de Klerk's talk, both in the technical and system orientation. And if you walked into my office with my angel investor hat on, and you said you could do these things, I'm going to, quantified life. I mean, every totally nerded out Silicon Valley person with too much discretionary income wants to really measure all these things all the time, set goals for themselves and like this. But instead, he's actually doing something useful for humanity. So I tried to goad him into saying, okay, now this is just a loss leader, right? And then you're going to really, he says, no, we're just going to do more work on epilepsy. I'm like, I'm still, you notice I'm a little faint when I hear that. Okay, so that was great. And then Chris Rowan gave a very representative application of this command recognition from Babel Labs, and I thought that was another very good one. Now, what's surprising is in these applications, anybody want to yell out, in what sense are these not representative applications? Where's the computer vision? I thought computer vision was driving, deep learning and tinyML and all that stuff. So again, I think we maybe went a little short on that. So other reflections on applications. Okay, we've heard it so many times, but out of the mouth of babes. One of my recent graduates was actually here. He's working on the startup. Was here yesterday at dinner saying, so is it basically 160 people gathered with a solution in search of a problem? Is that what it was? So out of the mouth of babes, it's kind of like that. So I thought it was interesting. I found myself posing, what's the Palm Pilot of IoT? But that kind of begs the question, well, what's even the personal digital assistant? In other words, we had the Newton. Those of you who remember, we had the Newton and all these old things that were supposed to be personal digital assistant. Finally, Palm Pilot got it right, and then that kind of evolved into the smartphone. But I don't even know if we know what the personal digital assistant is. And this is what I was trying to go Boris to engage in. It's like, well, what is it if we could just technically solve it? Then we're just really sure, man, that would have a huge market. Okay, so but it's a good challenge, and I like the idea we get enough bright people thinking about that and envisioning what's possible, then that will take care of itself. So other things I'd like to see as an audience member here is a little more automotive sensor integration. Those out at the very edge, as they get up and close to the sensors are in very low power regimes, wearables, augmented reality, virtual reality. And I joked about it, but I think if you know anyone who's had a health challenge recently or something, the prospect of quantified life, really keeping in mind that is very powerful. One thing that I didn't see addressed, and I saw just a hint of it at Pete's talk, and I never quite made it over there, but here's the dirty little secret of deep neural networks, or machine learning more broadly. You get a small shift in the domain representation of the data, and you get a big drop in results. And a researcher at Berkeley, this is unpublished, this is kind of hot off the press, has shown that if you simply try and do ImageNet and you replicate exactly the characteristics of the ImageNet test set as closely as possible, so you're not trying to just throw in some random images, you get a 10% shift, even if you try from a statistical standpoint to be as close as possible. Okay, now this was a closet machine learning, so we're going to bring machine learning back because we always knew those deep neural nets were fragile, right? Actually, no. So they tried dutifully their favorite machine learning algorithms, and they did even worse on the domain shift than deep neural networks. And as a matter of fact, the better accuracy the deep neural network was, the less it lost. But there's still, so there, this is, you know, as we beat to death ImageNet and so forth at academic conferences, there's a huge gap between that and if you actually go try and put this in an autonomous vehicle or any other application and just and begin to see the importance of the data set. So it does look like you folks are on to helping us address that and giving us a data set that's more representative. Yeah, so that'll push things forward. Okay, so then on top of, you know, again, despite my broad comments here, I'm principally talking about the applications and the software environments. And so we got a good representation from the embedded learning library from Microsoft and home court here, Pete Ward and TensorFlow. And again, Pete's been the champion at, back, he was leading mobile back with Jetpack, right? Maybe a little bit too far out ahead of the curve with computer vision on mobile. And now he's decided rather than enjoying the success at mobile level, he likes it out on the fringe and taking tomatoes and things like that at the very fringe. Why? I don't know. That's for Pete and his therapist, I think. Okay, so what about software frameworks? We saw, you don't have to walk out of here and go, yeah, I mean, had you ever heard of those before? TensorFlow Lite? I don't know. You don't know. This is the stuff that people are using. And, I know Chris really, brought out the guns and shot holes. But, I spent a lot of my, at least 15 years of my career in tools. And I often comfort myself walking out of, Sun or SGI going, well, customers only complain about the tools that they actually use. so that's good. Chris is clearly using TensorFlow Lite quite a bit. Yes. I'm always sad when we talk about the higher ends of the tool stack that we never at least kind of make an homage to the 30 or 40 years of mathematical library work that we're building on top of so that any of this stuff actually works. And I don't really think we want to get into knee slappers about, tall, skinny matrices versus, and so forth, or how we can save a few instructions than inversion or Winograd versus, straight up convolution. But I think somehow in there we got to at least educate the audience that that's a big piece of stack. My bigger gripe is that AutoML in the academic world I'm in is like taking over. I mean, so we heard a lot about quantization. Pete, I'm sorry, we didn't hear like, oh, and incidentally, for last year we've had papers which essentially show how you can do this automatically. Now, I'm not saying that just because, well, you didn't cite my paper. I'm saying this because, well, it'd be very interesting to see if the academic results are falling short in terms of the quantization you need, and that would be a sharp discussion for a workshop. Like, well, Kurt, you may think you solved quantization, but let me tell you what real quantization, and then benchmarking, it's open source software, benchmarking, okay, here's what those results, and this is if you really roll up your sleeves and do quantization, what you get. That'd be a sharper dialogue. I think that's just about it. So I hope, well, I brought a jovial attitude and affect to a whole bunch of criticism, but it reflects my sense that I do have an overwhelming optimism about this workshop and really glad to be a part of it.
Yeah. So Kurt, I was going to challenge you on the PDA analogy. Does such thing exist for IoT, or IoT is so fragmented you can develop one platform that covers it will be more like a Lego block type of approach rather than one thing that does everything?
I thought I was challenging you. I don't know what you're No, I think it's a fair question. I don't know. I'd pay $50 not to be bothered on the little vacation that I finally get because a pantry moth went by my motion detector. I'd change the battery every 6 months. I think you probably have to be, through an, sorry, question back? Well, let me just finish. Yeah, so I think you probably have to be through an experience. I mean, sorry. If they said you can buy the $5 sensor or the $50 one at the very beginning of building my alarm system, I'd want But you go through that once, you're like, okay, sure, you bet, I would. So I think, so coming at this a different way, if you look at the difference between China, I mean, it used to be we were leading markets for the rest of the world, and now I see China is very much leading, particularly in the consumer area, markets that make us wonderful to that. So clearly a lot of the surveillance in China is driven from the government and so forth. But now that it's there's a lot of very good uses for it, and that's the economics of that are pulling through. So I do think there's I'd like to have more home surveillance and so forth. So I do tend to think that intelligent cameras giving you information that you really want in a private way, that's as close as I come to a killer, I suppose. Yeah, okay. Marian, could you have a question?
Yeah, but it's on another topic, so if someone else want to continue on this, go ahead first.
You're too polite,
okay.
Marian.
I wanna continue on your last point about the AutoML. I strongly agree that this is the way forward, where the networks are going to optimize themselves based on some constraints. And I think what we have unique in the tinyML community is that our constraints will be very heavily driven by these resource constrained devices, almost no memory, but also no compute power and so on. And I think the next step forward there is finding a more structured way of how to represent these constraints so that they can easily be plugged in frameworks like TensorFlow and others to take this into the optimization loop. And again, for us hardware designers...
Can I break you right there? Yeah. Because I think you're also getting back to David's question. So there's two different, just to clarify, I just want to pull out two things. I mean, we'll do AutoML on reasonably big iron on the servers that we have to optimize. I think you're bringing up a point. Once we deploy it, then to David's point, we want to do continuous training and continuous optimization. And I'd say we're just a couple of years away from that. Yeah, I think we'll see it. I mean, I expect Google's already doing some. I think we'll see mobile, I would say, within a year. And I think we'll see small, then it'll be trickled down to the smaller platforms. So,
yeah.
Sorry. Didn't mean to steal your microphone.
What I wanted to add to that is we already see that the underlying hardware constraints very strongly impact what networks are optimal.
Yep.
So you can really not decouple them. And if you want to figure out how techniques like Naveen's in memory processing or our different parallelization schemes, whether they make sense, you really have to bring it in that loop, because maybe with existing networks, they don't make sense. But if you would take this into account when you make the network, it makes a whole lot of difference. Or not. But at this moment, we have no structured approach to figure that out.
Yeah, Marian, I don't know if this makes sense to you, but I want you all to say hallelujah, say amen. That's I think that's the wonderful perspective that you brought to this workshop. That's so important. That it's only by considering the application, the target silicon, the accuracy requirements, then you can begin to design the co-design the net and so forth. So absolutely, yeah. David wants to. Oh, sorry, there was a gentleman already. Yeah. Okay.
So I want to bring it back up to applications. Yeah. I think that's really important. And just a caveat, I'm also an embedded and communications expert. So ML is black magic math to me. Mm-hmm. But I can see its potential to change the world. So one thing I want to bring up for the community is technology for good. I mean, we mentioned Asia, but Asia is a very developed economy also. So yes, we'll get the state of the art, but what about Africa and Southeast Asia? There's so much that machine learning could do to fundamentally change how society runs in these areas. The ability to solve problems at the edge with minimal external input and interaction could really do amazing things. Yeah. One of the programs that we help sponsor is called Data Science Africa. And also Google and I believe Microsoft and a few others sponsor this. It's an amazing program where we go to Eastern Africa with the top universities and teach them about data science. We build hardware. Last time we tried to identify animals in parks with vision on embedded hardware. It's just fascinating stuff. So how could we make a connection between this community and the rest of the world where I think we can really solve problems? And maybe we can get to the point where we can improve society to the point that we don't need security cameras in your home because we're worried about the crime. So that's one thing.
Sounds great.
The other thing I wanted to stress is that there is not going to be one killer application. So I came through the entire IoT industry for the last 20 years. And I think one of the big misconceptions we had in industry was that we could just suddenly make this one magic platform or application that's going to run all of our business. But it turns out there's 100 different market segments within these embedded spaces. And you're not going to have one killer application for all of them. So I think we have to find great applications in different markets. And I think it goes beyond vision. We got to look at other sensors.
All sounds good to me.
Acceleration and others.
Like David.
This is more of a comment. You mentioned that we are under.
Can you hold the microphone like this? Just hold it in this way.
Yes. So this comment is that we.
David, I can see you've never been a rock singer. You gotta hold it like this. Just imagine Mick Jagger. There we go. Got it.
All right. This is a comment that you mentioned that we are underrepresented in CPVR and NIPS and
Right.
etc. I think we need to make more effort. After a lot of trial and persuasion, we have been able to actually get a workshop on embedded low power hardware architectures and accelerators at CVPR. Just so that you know, please come to. So we have a workshop.
Yeah, and we have the Peter and Pete and I are doing the embedded computer vision at coming up at CVPR. There's LPIRC. I saw Yurin Chen here, something like that. Yeah, there we go. We have that. So, but you hang out with real AI people, and you go, oh well, we have a workshop to go. Oh, that's clean. Yeah, yeah. Why don't you call your mom and tell her that, right? I mean, are you even going to put that in your Vita? I mean, the workshops are seen so much as, it's great for us to all get together and pat each other in the back, but they're, people like Jatinder Malik can talk about. Yes, I have a oral presentation at CVPR, which incidentally I do too this year. But that's what we have to see the concerns of this group actually work their way into the mainstream community, and that's a sociological issue.
No, I agree, because there was a workshop that you ran last year also at CVPR that I attended, but I think we have been fortunate to get another one included along with you.
Yeah, that's good. Yeah. I mean, that's progress for sure. Yeah. Maybe one more? No? Yeah.
10 seconds.
Yeah.
Make it a tiny comment. So I just want to disagree about the fact that the machine learning community is not aware or interested in these problems. So ICML and NeurIPS is my home community. I mean, I've been an area chair for both conferences at least the last 3 years. So I see the papers being submitted. ICML is right now in the final decision process of this year's conference. And because this is my area, kind of my keywords get all of these papers to me. So I'm kind of in charge of many of them, and there's tens of them.
So you're saying we should blame you if we don't get it?
I'm not the one who rejected the squeeze nets or whatever it is, but I am actually being pretty hard on these papers, and most of the reasons is that a lot of them are not meeting the scientific standard that these conferences have. So these are hardcore, very mathy, very rigorous conferences, and they always have been, at least for the 19 years that I've been involved in these communities. And a lot of these papers on the tinyML type of stuff are a little bit hacky and promise these 30x, 50x speedups, which are total crap. So don't ever believe a 2-digit plus X number when you read one of these papers. And they don't follow the scientific standard that we require.
Yeah. So
people are definitely pushing these in. And the other thing that indicates that these
can we kind of deal with one thing at a time? So I think that there's no doubt if you enter those communities, ICML, CVPR, and so forth, what you see over and over is like 2 or 3, maybe more pages of math, then the results table, which may or not or probably didn't draw exactly on that math, and that math may not be wrong. And Boris here, I gave him as a representative. Oh, here's someone we're thinking of inviting. ICML. I think it was ICML paper. And you'd have all the pages of math, so forth. Boris gave the problem to a student over a weekend. They did better with a neural net. He says, "Where could I publish it?" I said, "Not ICML. You don't have enough math." Right? So we can obviously. I'm kind of trying to get the last word here, but I think there's got to be a little bit of meeting in the minds that I was an undergraduate math major. I did my dissertation largely theoretical computer science. Math is as math does, and if I've got the choice between something that works and something that has a lot of mathematical foundation, I'll take what works. Yeah.
Yeah, well, thank you, Kurt. Thank you, Boris, and thank you, Ian.